The next workhorse data structure in Pandas is the DataFrame. This is similar to a 2D array with flexible rows, indices, and column names. To create a data frame, we're going to use a dictionary format data structure as well. So it uses a key value pair. So the left-hand side of this column, this will be the key. And then we use a list to populate the different values. So in this case, we have a string values here, 4 string values separated by a comma. For age here, we have integer values, and also city here, we have a bunch of different values. So dictionary, we use the curly brackets here. Then we save it into a new object. This would be a dictionary object. Now, to convert this into a data frame, we're going to use the Pandas here function called a data frame. Use the dot notation to access this, and then we pass this as an argument. So we pass our data frame here, our dictionary here as an argument, and then this will be converted into a data frame where we have rows and columns. So here the keys here will become the column, and then this will be populated as the values for each of this column. All right, and then we print it out. So once we do that, you can see we've generated a nice table here that has the name, age, and city column with the different values. And because we didn't include an index, so we have an index here automatically generated. Pandas generates that for us. Okay, so how do we access columns of the data frame? We can use the name attribute. So the name attribute, we can use it as like this. So we can just say print df, and then we use the square brackets. Then we say we want to access a specific. So remember, this is our data frame. So we use the square brackets and specify we just want to access this column name or the key. So when we print that, you can see it just generates for us the values in this column together with the indices. Okay. So similarly here, you can also access the rows of a data frame using the loc and iloc attributes. So let's start by looking at the loc attribute. So the loc attribute essentially looks like this. So we can actually use the data frame here dot loc, right? But now here, so when we print this one out, let's print it out. You can see it generates for us this. The loc here just selects the rows, column names with specific labels. But now, because we didn't have specific labels, we can now include the index, right? So when we include the index, so let's generate an index for our df here. To do that, we can just add the following. So the only thing we're adding here is comma and adding the index. And this index should correspond to the number of values that we have, 1, 2, 3, 4 for each of these values. So as soon as we do that, then we need to change this as a label, right? So we want to access maybe this specific A. So we print that. You can see now it's able to generate for us the specific contents, right? So you can see the name there is unarmed. So basically here, we just access the first row. Essentially, this will be unarmed, age is 26, and the city is New York. And that's what happens. Again, if you want to access by integer position, we use iloc. So notice the difference here. So again, these are just similar to one another, only that the loc here allows us to use the specific label. But the iloc here just gets the integer location. So if I change this maybe to 2, you can see now number 2 here is hope. Okay, uses the integer position. But if I want to access hope here using the label here, so I'll just change this to C. All right, then we're gonna generate that. Okay, again here, let's say we want to perform some mathematical operations on the data frame. So to do this, let's say we wanted to add, we want to increment the age for every individual by 2. So to do that, we could just simply type the following. So first of all, on this right-hand side, we are saying we want to access this column called age from our data frame. Okay. Then on the right-hand side is where we perform the mathematical operation. We're saying from this column, every value in our column here called age, increment by 2. Then store it in the existing data frame and then print it out. So we print that. You can see that all the ages here have been incremented by 2. Originally here we had 26, 28, 32, 37. Now we have 28, 30, 34, and 39. All right. So again, we can also use Boolean indexing to select a specific row. So suppose we want to pass a condition, right? So we want to just display content from our table for all the individuals whose age is greater than 30. To do that, we just type the following. All right. So from our data frame, we want to pass this condition. Notice how we are using the square brackets again here. So we're just saying in this data frame, we want to access this column called age and pass this Boolean, right? So this Boolean indexing. So we're saying for all the values in our column called age, return all those values that are greater than 30 and print it out. Okay. So this is what happens. So we can see only these 2 records satisfy that. That's what we have. Again, here we've already seen this. If you want to get a summary statistics for our data frame, we just say df describe and just gives us the count, mean, max, and so on and so forth. And then lastly here, we can also use the group by. It's an aggregate function that allows us to, for example, if we want to just group the data frame by city and get the mean age of each group. Okay. So to do that, it's very simple. So just type something like this. So we just access the group by function. Then we specify that we want to group by city and get the mean. Okay. So what that means, it will check for the column names that have integer values, and then it will get the mean for each of those groups. So in our case here, it so happened that age column is the one that only has integer values. So it'll just get the mean, then group that by city. So you can see, so if we had a large data set, you will see the summary of the different values here. So like if we had New York that had 1,000 people, we should be able to see a mean age for that. So in conclusion, data frame can be viewed as a generalization of a 2D NumPy array, right? Where we populate our data into rows and columns, right? And then we can also include an index or labels to make accessing the data much more efficient. Next, we're going to look at some of the capabilities of Pandas, like importing data, reshaping, aggregate function, and how to handle missing data, among others.